Hello, and welcome to CAD Builder version 1.4.0. The biggest update to the program is grain matching fronts. This is done by assigning grain matching groups to cabinets, with each group representing a sheet of the associated material. There are multiple ways to assign these groups. We'll start by going to the application settings, and you will notice a new tab called Design. If the grain match mode is set to none, then the grain matching will not be automatically activated and will rely on your manual input. If you set it to per cabinet, then a grain matching group is created for each cabinet individually without trying to match it with surrounding cabinets. While if you set it to automatic, this will prompt the program to automatically assign grain matching groups limited by the material width and height set below. And for this example, we'll set the width to 47 inches and the height to 95 to account for CNC tool bed diameters and trims with vertical grained fronts. Let's see how it works out in practice. We will begin with a new design. So let's start in the design right here. We'll drop in some walls, and we'll be dropping in our cabinets and our grain matching groups within the elevation view. So let's get within wall A's elevation view, and we'll start placing some cabinets, beginning with some drawer stacks. So we'll go over to the left. I'll drag in a 3-drawer stack, and notice as soon as I bring it in, I have a bottom label called grain 1, and this is just the first grain group assigned within this design. If I bring in another cabinet, it will be automatically a new group unless it detects it is close enough that it can fit on the same sheet. So once I drop it in place, we can see that this one also enters group 1. I'll drop in a 4-drawer base as well. These are all 12 inches, so they should all fit within the same sheet. These are all group 1. Now the next one that I'm going to bring in is a full height door base, 24-inch deep. If I try to place it next to the grain 1s, we can see that, of course, it cannot fit on the same sheet, so it will go now to grain 2. And we'll bring in now a tall cabinet. Utility tall, we'll make it 18 wide. Drop it next to grain 2, and we'll also bring in a wall cabinet after this. Let's say it's a 2 shelf. We'll make it also 24-inch deep. Now we can see that the wall cabinet will be automatically selected with a different group because it is separate from the base cabinet, but we can manually override this by selecting the cabinet, go into its attributes, and you'll see a new section called grain match group. You can use the drop down list and select it to be, instead of grain 3, we'll use grain 2. And you notice when you override it, it becomes italicized and bolded, meaning that we manually locked it in place. We can see a summary of these assignments by clicking on a cabinet, going again to the grain match group section, and clicking on the edit button next to that drop down. So here's a summary of what's going on. We have 2 grain groups. Each group has 3 cabinets in it, and you can see the one that's been manually overridden has a little lock label next to it, meaning that no matter what that automatic algorithm says, this one will always be group 2. You can create new groups from here, you can delete them, you can rename them. If you click on the reset button, this will reset all the manual overrides and recalculate the grain groups. You can do this individually by selecting the cabinet and clicking reset, or you just click without having anything selected. Reset will just reset all the cabinets. Grain matching only works for slab and MDF one-piece doors and is relevant only when the front materials are grained. So we'll go back to the design and we'll go to our design options and we'll assign some basic assignments. Starting off the construction method, we'll say that we're using the, let's go with framed standard overlay. And I'll do the door material assignment with some grain material. And my lower door, upper door, and drawer from construction, I'll select slab doors with vertical grain directions. And I'll also assign a finish just so we can more properly see the result. We'll hit apply. Now if we check out a 3D and zoom in, this would be a representation of what's going on. You can see the grain goes through the front, continuing on to the vertical portion at the top. That is ideally what we would like to see when we send this to the CNC. Now that our doors are complying with our grain match assignments, let's try to optimize this and see how it turns out. So we'll go to the cut list, configure and optimize. I will not be using any remnants, and I'm looking just for the doors, which will be the 3/4 inch G1S plywood birch. Actually, this is a double assignment. I've assigned this other 3/4 inch single-sided plywood birch to it. My nesting settings are as normal. So let's now hit optimize. And this brings us to the optimizer section. And you'll notice the doors, when they're laid out like this, they're going to be highlighted in yellow. And those represent doors that are part of some grain match group. Now, if you select one of these doors, the entirety of the group will be highlighted in orange to show you exactly where they're going to be lining up. So because of the spacing of the doors and the overlays and the cabinets, we can see there's some extra spacing in between the pair of doors and the utility cabinet. Same for the drawer fronts, where you have significant width in between them, so that spacing is kept constant. Now, CAD Builder will attempt to keep this constant spacing, but it will move these parts if needed. For instance, if I was using some full overlay assignment, where I'm keeping 1/8 inch reveal between all the fronts, but all I have to work with is a 3/8 inch compression bit, then CAD Builder will still nest those, will attempt to match them as best as it can, but obviously we'll have to make the spacing 3/8 as opposed to the standard 1/8 of an inch. Although in this case, we have enough space between them that doesn't happen. Now, as previously seen with that wall cabinet, you can manually assign groups, grain matching groups to your cabinets, and that can result in broken grain matches. For instance, if I were to go back now to the design and bring in another wall cabinet, let's say it's a 24 inch one, and I'll try to match it with grain 2. This already goes over the 45, over the 4 feet width measurement that I'm looking for. And if I try to nest it, it will have to break up the doors to make this happen. So for now, if I go to the cut list and I configure and optimize again, and optimize my doors, it will tell me, hey, grain 2, the group has to be split in order to be able to nest it. And if I click return, it won't do that. It will allow me to go back and maybe review some of my assignments, if there's something that I would like to change. But if I click confirm, the optimization will go through, and here's that grain match 2, but the pair doors from that wall cabinet are then brought over to this other section. Now, going back for a second to the design module, these grain matching labels can be turned on or off for both the plan and elevation view. So if I were to go to the application settings and I go under display and I check on, for instance, the display group label on plan view, then it will display it here too. So I can either see it within the design, plan, or elevation view, but of course it makes a lot more sense to view it from the elevation view because your doors are in this plane. While on the topic of the elevation view, 1.4.0 also brings assembly dimensions within this layout. So if you go to any walls elevation view and you just click on empty space, you will see the grid attributes over on the right. And if you scroll down, there's an assembly dimensions section where you have a checkbox for opening sizes and front sizes. So if you check on front sizes, it's exactly what it sounds like. It brings a label onto each front, giving you the size of each door or drawer front. So especially useful for installation when you have, let's say, a pile of doors or drawer fronts, you're not sure where these go. This is a useful thing to print out and see where they all land. It also gives you a very good idea of what's going on within the design itself. As opposed to the opening sizes, which will toggle labels for the cabinet assembly openings. And this acts in different ways for frameless and framed cabinets. Now, right now, I am within a frame construction. And what it does is it gives me the sizes of the openings from frame part to frame part. So for instance, if we look at this utility cabinet, the distance between the top rail and the mid rail, the inside space, is 24 3/4. And from style to style, it's 15 inches. And same for the bottom opening here, I have 15 inches wide, 56 1/4 tall between the bottom rail and the mid rail, the inside dimension. If we look at this drawer stack, we have 5 by 9, 9.5 by 9, and 9.5 by 9, so on and so forth. But if we were to switch it to a frameless construction, let's see what that looks like. I'll do frameless by Joint Full Overlay. The frameless will instead do it from shelf to shelf and partition to partition. So this utility cabinet, for instance, has 25.5 inches between the top shelf and the fixed shelf. And then the bottom opening 57.75 between the fixed shelf and the bottom shelf. And then from side to side, we have 16.5 inches inside opening dimension. Now, for frameless, this will ignore adjustable shelves, you will ignore rollout shelves, rollout trays, and closet rods. You will just consider drawer stretchers, fixed shelves, possibly simple shelves, and just sides and tops and opening case parts, so to speak. For framed cabinets, the opening sizes are just the frame opening sizes. We will ignore adjustable shelves and any other shelf that might get in the way. When you turn these on, this will also be present in your printouts. So you could maybe print out the opening sizes and then uncheck that and print out the front sizes. You can also bring them both together at the same time. Mix and match to get whatever you need. Now you may have noticed that your grid attributes has another new section called Design Light Adjustment with an intensity field and an intensity bar. And this represents the ambient light of the room. Ambient light being just the uniform light that applies with no particular source location, so it applies everywhere. And when you turn it up, it of course changes your 3D view accordingly. It will interact also with any other present light sources in your room, and that can significantly affect how your 3D view is rendered. For instance, if I turn it all the way up, we don't really see any shadows anymore because the ambient light is overpowering the room light. I can also disable the room light altogether so there are no shadows at all in my 3D rendering. So mix and match your light sources, including your ambient light, to get what you're looking for. Lastly, for your design module, we also have color themes. So if we look at the application settings, you'll notice a new section called Appearance. The first section here, Plan Elevation Themes, you can select the color theme for your objects in the Plan Elevation view. So default is just the default white shaded objects. High contrast would be high contrast color. You got low contrast and monochrome, which would be just in black and white and shades of gray. Or you can set it to custom and manually set the color for each object type. Whatever you pick, this will affect the colors of the objects in your design. Now you also have the selection section, which allows you to change the thickness of your selection bar and also its color. So this is present whenever you select something in the design view. You will notice the outside is highlighted in that color. You'll also notice it in your wireframe. So if you go to the wireframe and where you are to select a part, that color would change. And the final section there is for the warnings and errors color. So these represent wherever the warnings and errors menu will appear. For instance, if I click on this, we have the warnings right there, and the color within it can be switched as well. The last new feature we will check out in this video will be the implementation of the lock dowel fastener within Cap Builder. Let's just do a brief example of that. So just like any other connection, you have to go to your construction methods, construction connection, and set up the connection in here, set up its specs, apply it to your cabinet construction or your drawer front construction, and put it to use. So you'll notice a lock dowel template right here. We will create a new joint. Let's name it just lock dowel. We will use this for, let's say, the bottom to the side connection, and we'll have it such that the bottom will have to be pushed backwards to lock it in place into a full panel side. So let's set the lock dowel type first. You can either set it to a channel lock, where it makes a channel and allows you to put the part in place and then push or pull to lock it. Or you can set it to H-clip, where it's effectively a dowel implementation. You just push it in and it locks in place. We'll use a channel lock in this case. Lock dowel channel lock shape, so it comes in different shapes and sizes. We'll use just a standard barbed channel lock, though we have the mini ones available as well. And then you pick the orientation for it. Now, as I mentioned before, we want the bottom shelf to slide backwards to lock it in, so we'll set it to not inverted. The lock pinhole diameter and the pinhole depth, these are the specs of the lock dowel holes. We'll keep them as they are. I believe this would be somewhere around 8 millimeters. And then the arrangement, so like any other dowel or hole boring connection or fastener connection, you're selecting how many there should be and where they should be placed. I'll do mine in a fairly simple fashion. I'll say front to rear, where I first specify where the first lock dowel will be. We'll say the first one is 3 inches. Its center will be 3 inches away from the front edge of the bottom. And then we'll apply, I'll say, 1 every 10 inches. So the spacing I'll set to 10 inches. All the way back to a minimum distance of, we'll say, another 3 inches from the back edge of the bottom shelf. Parts gap I will leave at 0. I will want the CNC to make this happen. So if you're setting it to the CNC, we'll cover shortly how that is set up. And then the lock dowel connector, we'll just use the standard lock dowel E900BP. Alright, now let's see how this is going to look like in the wireframe. Alright, with the connection assigned and the construction connection selected, we go to these cabinets and we'll see where they end up. And here are my lock dowels, bottom to the side connection. Now I probably will need to maybe make the smaller distance from the back edge, smaller minimum distance, or perhaps adjust the spacing here, but this will do for our example. Let's see how we can send this to our CNC. Now, of course, the CNC will only be able to make the channel lock on the face of the side. It won't be able to do the edge boring on your bottom shelf because that would require another machine or some kind of jig. But let's see how we can make the channel lock happen. So if we go to the cut list, your tool set will need to have a lock dowel bit, a specialized lock dowel bit set to that lock dowel operation. So we will represent this within CAD Builder by going to our tools library, tools section, and over at the bottom we'll see 2 new tool bits. We'll see lock dowel mini and lock dowel, depending on which bit you're going to have in your shop. We'll choose the lock dowel for our example, and all the parameters are already in place other than the feed and speed rates. I'll set mine to constant. Let's say 18,000. I'll do a feed rate of 250, a plunge rate of 150 inches per minute, and then I'll assign in my tool set. So I'll go to my standard tool set, bring in the lock dowel bit. It's in position number 5 for me, so I'll use that. And now if we configure and optimize, it should let us go through. I'm looking just for my size for my case part, so I'll use 3/4 inch single side plywood birch. I'm not going to use any remnants, and then I'll hit optimize. Alright, so here are the layouts. We can see already the channel lock in place. We can check out our toolpaths for the simulation. So if we click on, let's say, this first sheet, start the simulation, it's going to do the drills first. So it does those drills. We'll skip ahead a little bit, and then it should handle the specialized. So there it goes. Lock dowel bit ramps in, makes the channel lock, goes back out, and then it does the rest of it. So with our lock dowel operations in place, our CNC will make the channel locks, and then the adjacent parts, the associated parts that will accept the actual lock dowel first before making a channel lock, that will be handled by some jig or by some other insertion machine outside the normal nested CNC router.